Okay, so we did our titration. One of the things to kind of note is if you've got data all over the place, it's going to be very hard for you to figure out which numbers do I want to put where. Oh my goodness, I can see my beard. I need to trim my beard. I got like things sticking out there. Anyway, if you've got data all over the place, it's hard to tell what's what. So you want a nice organized data table with your information, right? Labeled acid volume, base volume. You can't tell that's the word volume. I just looked at that and I was like, KL. No, it's a VOL. I just, whatever. Right. So I understand some of us have good handwriting. Some of us are more naturally organized. But with your lab data, make it organized. That's part of the grade anyways. Anybody should be able to look at that data and tell what's going on pretty quickly, right? But so this doesn't become an hour-long video. Let's run through the calculations. Also, nice and organized with our calculations. Like your first calculation should say moles of base, and then that calculation should be right there with things labeled in it, and then moles of acid and whatever. I'll do those down here because I want to, these are the 4 calculations we need to do, but I'll do those in color and then erase. So for my first one, moles of base. So for moles of base is my goal. And I always think thinking of what do I have, what do I want kind of stuff. So I start thinking about my base and I say, well, I've got a volume of base of 11.9 milliliters, right? That was what you put out of your burette. You had the base in the burette. You got the acid from up front with me. So you have some volume of base. Your acid is probably 10 milliliters each time, but maybe one of the times you didn't get 10 milliliters. Your base will not be 10 milliliters. We spent all this time with the burette so that we could get good numbers. So we shouldn't just take some round number that we kind of glance at, right? We should go to at least the nearest tenth of a milliliter. You can actually estimate beyond that, but students don't have a lot of experience with that, but you can do that, right? It's not too tough. So anyway, I'm going to take my volume of base, my 11.9 milliliters, and then I say, well, I've got moles of base, but other information that I have that maybe would even be good to put in my data table, hint, hint, is I know my concentration of my base. Mr. Fredrickson gave us 0.10 big M. Well, that big M is moles per liter, molar, right? So I'm going to multiply this by 0.10 moles of sodium hydroxide for every 1 liter, because that's what that big M stands for, is moles per liter. So this looks really nice, except for one thing. I've got milliliters here and liters here. So I either need another conversion factor right here to change milliliters to liters, or what I could do is I could do a side problem and I just move the decimal point, right? So I kind of like moving the decimal point. So I'm just going to rewrite it there. So if we go on the back of our periodic charts, we've got milliliters right there. My finger's right next to that. To liters is a base unit, so I'm going to move my decimal point 3 places. So 3 places to the left, 1, 2, 3, right? So I got my decimal point, 1, 2, 3 places to the left. So I'm going to rewrite this, and on our lab report, right, we would want to show this in like a pre-problem basically. So 0.0119 liters of base. So if I take 0.0119 liters of base, multiply it by 0.1 moles per liter, my liters cancel out, and that's going to give me moles of base of 0.00119, right? There's an extra 0 now because of the 0.1 moles of base. I mean, that's how many moles of base it took us to titrate that, right? So that's what we're going to do. A calculation like that is what we're going to do. You'll just have to keep track of what your numbers are and that kind of stuff. But don't use a volume of acid and a concentration of base. That doesn't work, right? That doesn't tell us anything. So this, for my numbers, this is not your numbers, right? But for my numbers, it's something like this, right? 0.0119 moles of base. So then we say, well, moles of acid. Well, can I do a similar kind of calculation with acid? Well, we know a volume of acid, but I don't know the concentration of acid, right? We said that's an unknown. If you look back to the purpose, we have an unknown concentration of acid. It's a diluted vinegar solution. I took vinegar and I did a 10-to-1 dilution, but we don't know the concentration of that. So what we're going to do instead is the whole purpose of the titration. You stopped, should have stopped. You can't really tell. That's really, in here you can tell. It's blue, right? The point of blue is that it's neutral, pH 7, right? Well, pH 7 is that blue color. That doesn't mean no acid and base. It means equal acid and base, right? We talked about that with the pH, POH scale. That means equal amounts of acid and base. Amounts. moles are amounts, right? So if I have equal amounts, I have equal moles, I have equal molecules of acid and base. So if my moles of base are this and I stopped at blue, then my moles of acid are the same. So you say, Mr. Fredrickson, I stopped at green. What do? You redo the titration because you weren't at pH 7. That means this statement is not true. So you've now gone ahead with like bad data or whatever, right? Okay, so no molarity of acid would be my next one. So for my molarity of acid, and again, I don't just want to do calculations wherever, right? I want to do the mole of base, mole of acid, molarity. It should say molarity of acid, and then you should do that calculation so it's nice and organized. So molarity of acid, well, molarity is moles per liter and of the acid, right? So I need moles of acid per liter of acid. So let's just think, if you, and molarity is kind of like speed, right? Distance is how far you go. Moles is your amount. Molarity is your concentration. Distance is how far you went. Speed is how fast you're getting there. So it's a similar kind of relationship there. Miles per hour, moles per liter, right? So I'm just going to take my moles of acid, which I just calculated, 0.00119 moles of acid, and I'm going to divide it by my volume of acid. So I go here, but not volume in liters, not volume in milliliters, volume in liters. So again, I move my decimal point 3 places. So my volume of acid is 0.01 liters of acid, if this is the volume you used, right? If you used a different volume, right, you'd use the volume that you had. So then we'd move my decimal point 2 places, and it's, right, because that's 2 places there, so 0.119 moles of acid per liter, or 0.119 molar for my acid. That's not what it should be, right? That's not like what you should be going for. That's not the right answer. I just made up some values and put them up here, right? So that's my molarity of acid. I don't like that we used 10 milliliters and stuff everywhere, but I was trying to use those little burettes to help you learn how to use the burettes and stuff. So we ended up with some weird volumes and all that kind of stuff, right? So now let's use our, now we do our last calculation is very simple. It's just a molarity of vinegar. So this was a 10-to-1 dilution to get our acid. So our vinegar was 10 times more concentrated than that. So we would take this value times 10, right? Because if I do let's say I double the volume of something, then I've cut the concentration in half. Well, I did, for every 1 milliliter of vinegar, I did 9 milliliters of water. So I actually did 100 to a liter, right? So I did 100 milliliters of vinegar to a liter of water. So we do this, and it'd be 1.19 molar would be our vinegar. Again, that's not right for vinegar because I just made up values and whatever. But anyway, that's that. Hopefully this is helpful on your calculations. With calculations in labs, be systematic, label things. You should be able to tell, your lab partner should be able to tell, I should be able to tell, what things are what. No numbers just off to the side, done in your head, that kind of thing, right? Because it's a lab. It's kind of like a paper, right, for English. And I'm going to not shave my whole beard, but that's nasty.